What is data drift and how to monitor ML models? Imagine your machine learning model is like a car on a road trip. Over time, the road conditions change, and if you don't notice, your car might not perform as well. That's similar to what happens with data drift in machine learning. Data drift is when the data that feeds your model changes over time. The patterns, trends, or relationships the model learned at the start no longer match what it sees now. This can cause the model to make mistakes or become less reliable. There are two main types of drift to watch out for. The first is data drift, which happens when the input data itself changes. For example, if a sales prediction model was trained on data from physical store purchases, but now most sales happen online, the data distribution shifts. The second is concept drift, which occurs when the relationship between input features and the output changes. Think of spam email detection. What was once spam might evolve, making older models less effective. Monitoring these changes is essential once your model is in use. It's like keeping an eye on your car's dashboard to catch any warning lights. One way is to compare the statistical properties of incoming data with the original training data. If the average, variance, or shape of the data distribution shifts significantly, it's a sign of drift. You can do this by regularly checking the mean and variance of key features. Another important step is tracking how well your model performs over time. If accuracy, precision, or recall drops, it might mean the data has changed enough to affect predictions. For example, if a fraud detection model suddenly misses more fraud cases, it's time to investigate. You can also check if the relationships between features and outcomes are changing. If the correlation between certain features and the target variable shifts, it might indicate concept drift. Using specialized tools can automate this process. Many software libraries now offer drift detection features that analyze data streams and send alerts when anomalies appear. These tools help catch issues early before they impact your users. Infrastructure monitoring is also important. Changes in data pipelines, software updates, or external factors like new regulations can cause indirect drift. Keeping track of these changes helps you understand the bigger picture. When you notice drift, retraining your model with recent data is a good way to adapt. This keeps the model accurate and relevant. For example, a language model like ChatGPT needs to stay updated with current language trends. Image models like DALL-E or Midjourney also benefit from monitoring to ensure they generate relevant images based on recent data. Ethically, keeping an eye on data drift helps prevent biased or incorrect decisions. If the data changes and you don't update your model, it might produce unfair or inaccurate results. Regular monitoring builds trust and ensures your AI systems remain as fair and effective. In short, data drift is a natural part of deploying machine learning models in real-world settings. Monitoring involves checking data and performance regularly, catching changes early, and retraining when needed. This process keeps your AI tools working well, staying accurate, and serving users fairly over time.